All right, so graphic cubics. It's supposed to say graphing cubics, so I'll change this after. But graphing cubics. There we go. Perfect. All right, so we have a cubic. We're looking at this function here, y is equal to x cubed minus 2x plus 5. So we have an x cubed here. So x cubed, this is why they call it a cubic. And if you look at graphs on Google here, on what cubics normally look like, they have two shapes, and I gave you a handout. So it has this sort of like shape like this, where it comes down, flattens out a bit, and comes up. So that's one form of cubic. Or you can get the other one, which has a hump here and a dip there. So goes up, then down, then back up. So if you look at all these cubics here, there's no other form that you can see. Look, coming up, flattens, keeps going up. Going up, flattens, keeps going up. Coming down, flattens, keep going down. So they can switch ways. So if your cubic doesn't look like one of these when you graph it, then you have some problems. All right, so here we go, up, down, up, down. So depending on what you plot, the points that you plot, you should have something that looks like that. So let's look at plotting these. Well, we have y is equal to x cubed minus 2x plus 5. And they give you this table here, and they say it's between -2 and 2. So here I have my x -2 and my x positive 2. So our cubic should be flowing somewhere in this area here, okay? Now they've already given me a few points, for example, -2, which is right here, and they have y is equal to 1. So if I plot that here, that's right about -1, 2, -1 point, right, -1, right there. Oh, change color. Hold on a second. Take that one, and now it works. So that's our first point there, okay? Now we can try and put some of the other points if you like, or we can figure out these ones. I'll do these after the blank ones. So -1.5 is, well, -1, 0.2, 0.4, 0.6, 0.8, 0.2, so -0.2, 0.4, 0.5 should be somewhere along here. -1, whoop, -1.5, somewhere in here. So if it's at -1.5, we're at 4.63. So 1, 2, 3, 4. If I go along here, it's 4.63, maybe somewhere around here. Okay, so it starts flowing up. Next we have -1, -0.5. We'll get those. At 0, we hit 5, so that's here. So maybe it's that curve that flattens out. Maybe it goes up, maybe it goes back down and back up. We have to see what the points do. Okay, let's see. 0.5, which is here, 0.2, 0.4, 0.5. That's about 0.5 on my graph. So 0.5, 4.13. So this is 4, maybe around here, 4.13. So it actually is starting to go down here. So maybe it goes up and then goes back down. And now what do we have? No other points. So now we have to find these points here. Here. So I'm going to use one as an example. I'm going to find one point using writing out my equation with -1 in here. So if x is equal to -1, you should have -1 cubed minus 2 times -1 plus 5. And so if we do that on our calculator, -1 cubed is -1. -2 times -1 is positive 2, and then plus 5. So you should get, for this one, 7 minus 1, 6. So we have y is equal to 6. And I use my calculator, and according to my calculator, we have 6. Perfect. So at -1, which is here, you should be about there. So far it looks like it's going to go up and then back down. So this is 6. We figured that out. So using your calculator, you can find out these other points. So put them into this equation for your x's. Okay, make sure you put brackets around your x. Okay, please do not put -1 cubed and such. You always want to wrap them up whenever you replace x. All right, and if you do this for the other points, this one ends up being 5.875. 5.875. At 1, we get a nice number 4. At 1.5, we get 5.375. And then at 2, we get 9. All right, so let's plot these other ones. So negative 0.5 is approximately in between -1 and 0. So 0.2, 0.4, it's about here. And we have a y value of 6. So if we jump all the way up here, we're right there. So nice flowing parabola. Pardon me, not parabola, cubic. All right, so cubic. Next, at 1 we have 4, which is right about here. Okay, so it comes down. It's a little bit under the 4.13 we had here. So it continues to go down. And finally we have the last two, 1.5, which is about here, and 5.375. So if this is 5 and this is 6, we should be around maybe right here. And then 9 is way up here. So now we should look at this thing and say, well, that looks kind of like a curvy sort of thing, doesn't it? All right. And now the fun starts, me trying to draw this thing freehand. So let's see, it goes up like this, down like this, and up like that. It touched it. So there we go. That is our cubic. Okay, so once again, notice it's one of these. It's not this type. It's this squiggly one that goes up and down. Okay? So, cubic, drawn, points, in. The next question, it says, use your graph to solve the equation this is equal to 3. So, we already have this graphed right here, okay? So now what we need to do is graph this side. Well, how do you graph y is equal to 3? Well, that's quite simple. We take a line here, and y is equal to 3 is, well, this is 3 here at this spot. So y is equal to 3 should be somewhere like this line. It's not exactly that much. There we go. So, and what happens when this parabola or this cubic crosses this line 3? Well, that's the point where they share the same x's. So your point, what they're looking for when they say solve, they're asking what x is shared. So the x that's shared is, let's see, approximately, if I go up, maybe around there, depending on how great my parabola is, somewhere in this area here. So I get negative, let's see, this is -2, this is -1.8. So somewhere in between negative, right here is 1.6, and this is 1.8. So somewhere in between -1.6 and 1.8. So what you can do is, if your graph is accurate enough, you should be able to get a point there. Now, when I check in my calculator, I can figure out what that point is by finding the intersection with it. So if you have a graphing calculator, you can graph one side, graph the other, and find the intersection between the two. And with the graphing calculator, so this is part B, I end up getting a value of -1.76. All right, so is that about 1.76? Yeah, it's roughly there. We can get an approximate value over there. So if you're off by a little bit, obviously I'll be able to see. It all depends on how accurate this graph is drawn. If you have a calculator, it's always helpful to be able to insert the point and graph the two and find the intersection of these two lines. So there's graphing a simple cubic and solving the equation when the cubic is equal to a constant number here.